Alright. Yeah, Paige.
I didn't get the same like box foundation.
Okay, so what do you mean? How's yours different?
Like the second dot, I don't have in the same spot.
Your second dot?
Yeah,
What was it?
like 72.
It should be 72.5.
Yeah.
Should be that one. That one's wrong.
Gas.
Alright, good catch. You're the first person to catch it. I've done this 3 times now. Alright, any other questions? Alright, so Friday. Friday, Miss Howard talked to you. You did how to make all the graphs, right?
Uh-huh.
Today we're going to talk about answering questions off of them, pulling numbers off the graphs. I'm going to check. So, we're talking about a box and whisker plot right now. Let's look at it. Thank you. Test scores as a percentage for 6th period Spanish. What was the high score?
102.
102. How'd you get that? It's the max, right? The one all the way to the right out here is our maximum. So 102 is the highest on the test. What's this one down here? 38. It's a minimum. What does 72 represent? Lower quartile. What's 88 represent? And 96? Upper quartile, right? I'm just going to label them all. I figure that'll be easiest to answer questions later. What percent of the class scored above a 72? This is a good question. I like this one a lot. Well, what's my data broken up into? What are these things called? Quartiles. So they're broken up into quarters or 4 parts, which means between each one of my data points is 25% of my data. So between the minimum and the lower quartile. All right.
Place the mid roll right here.
Mr. Aldrich.
Jesus.
Hey. I do. Will do. Thank you.
Yeah, you didn't have
Jalen, your grandmother's picking you up after school.
Okay.
Alright, so between the minimum and the lower quartile is 25%. Between quartile 1 and the lower quartile and the median is 25%. Between the median and the upper quartile is 25%. And between the upper quartile and the maximum is 25%. Right? It's broken up into quartiles, quarters. So 25% of my data between each one. So now if I ask you, what percent of the class is above a 72, you would say?
75.
75%. Because I have 25, 25, 25. Alright, alright, alright.
Oh, good.
Why you gotta do that?
So, what is the median score on this test?
An 88.
88. We said that already, right? We said 88 was the median, right? That line in the middle of our box. What percent of the class scored between 88 and 96? 25, right? It's just between the median and the upper quartile.
I don't
That's 25% of my data. Alright. Do you think the test was too hard?
No.
Why do you say no?
Because
Because they did good. What does that mean?
the median was an 88, and that's pretty good.
The median was an 88, right? The middle score was an 88. That's pretty good. Does anyone think it was too hard?
Yes.
Why, Tommy?
Because tests are hard in general.
Because tests are hard in general.
And Spanish
Does
sucks.
anyone have any mathematical reason for why the test would be too hard?
No.
Some people didn't pass.
Because some people didn't pass. Right? 25% of our students, so a quarter of our students, got less than a C. You could argue that. Hey, with these problems, guys, they're opinionated questions. Right? You could answer yes or no to that question, and you could still be right, because you need some mathematical reasoning to explain it. So if you just put yes and you don't put anything, I'm going to mark it wrong. If you just put no and don't explain anything, you're going to mark it wrong. If you put yes, it was too hard, because a quarter of the students got less than a C. Right? 25% of the students got less than a C. That's a good answer. You can say no, it wasn't too hard, because 75% got above a C. Or the middle score was a B+. Right? Use those median, the percentages that we know. Use that math to put a reason behind your answer. Same thing, would you expect the mean to be above or below the median?
Above.
Why do you say above?
Because there's more people above.
Well, it's 50% above it. Paige,
Could you put like around the same?
you could say around the same, why would you say around the same?
Because 50% did worse and 50% did better.
Okay, so you're using math to explain it, perfect. Listen, I really don't like this problem, because we really can't answer this problem. Right? We don't know the data set. We don't know how many numbers are down here and what those numbers are. Right? I could have 25% of my data that were like 40%, and that still stretches it out like this. Or that 25% could all be 70s. That'll make the mean go higher. Right? There's really not a good answer to this question looking at a box and whisker plot. I always like to think of it as, you know what? My minimum is way farther from my median than my maximum, so I think it might be below. So I think it might have some scores back down that far. But if you put above and you said, well, 50% of the class scored really high. That works for me. Right? 50% scored above it. You'd say right around the same because the median's right in the middle of kind of my IQR almost. There's not really a good answer to this question. I really don't like the question pertaining to the box and whisker plot. But as long as you're backing up your answer with some sort of mathematical reasoning, that makes sense. Right? We can't just say some random 2 + 2 = 4. But use mathematical reasoning to justify your answers when it says to explain. All right? Any questions? Let's keep moving. Data shows the score of a die each time it's thrown. What kind of graph is this?
It's
A what?
A bar graph.
A bar graph, Sarah. How do you know it's a bar graph and not a histogram?
This is space.
Thank you, Sarah.
You're welcome.
Does that mean that those are...
So, yes, it is a bar graph and not a histogram because there are spaces in between them. Right? There's spaces in between the bars. It tells me it's spread out. They're different data pieces each. So, how many times was the die thrown?
A lot. It was.
20.
I don't know. You guys tell me.
It was 20.
How do you know?
You
Yeah.
add them.
Yeah, add all.
Add them.
The
1 +
frequency.
2.
No,
it's
it's
the
the frequency.
Add the frequencies. Oh, all right. So 1 happened twice, 2 happened 6 times, 3 happened once, 4 happened 3 times, 5 happened 5, 6 happened 3. So I add 2 + 6 is 8, + 1 is 9, + 3 is 12, + 5 is 17, + 3 is 20. So how many times was the die thrown?
20 times.
20 times. All right. 20 times. All right. What is the mean score thrown? I don't know. It doesn't tell me that.
Well,
Just put it in. What do you mean put it in your calculator?
You just do
So what do you like? How do you do that, Emma?
1, 2 times 2, how many ever?
Perfect. You could put it in your list, right? You could do 1, 1, 2, 2, 2, 2, 2, 2, 3, 4, 4, 4. You could do it for all of them. Put it in there. Do your one variable stats. Perfect. Awesome. That's one way. Right? That's another way.
Think you just do the frequency on two?
You do what?
I mean, like,
You could do, yeah, you could put like 1, 2, 3, 4, 5, 6, list 1, put their frequencies in list 2, and use the frequency list. Boom, another way you can do it with your calculator.
Wait,
How else could you do it, Jared?
just do like the frequency times the score and then add.
Perfect. You could do the frequency times the score and add them up.
Can I go to the bathroom?
Yes, you may. 2 times 1 is 2.
You need to like fill that.
Plus, just go. 2 times 6 is 12. Plus, 3 times 1 is 3. Plus, 4 times 3 is 12. Plus, 5 times 5 is 25. Plus, 6 times 3 is 18. Right? So you could do it in your calculator either one of those 2 ways. That's awesome. Right? Great use of technology. Otherwise, we can add up all of our scores here. We get
74.
72.
72
I just can't.
over 20, right? How many times we rolled the die?
Wait.
So it's approximately, if I did my mental math correct, 3.6.
Yeah.
Awesome. Question page?
No. I just can't type into my computer.
Okay, we'll work on that.
Good.
Number 3, if I'm betting on the number 5 for the score to show up. So we did 20 rolls. Every single roll I bet on the number 5. How many times did I win? What percent of the time did I win?
25%.
How do you figure that?
Because they rolled five times.
Because we rolled 5 times out of 20, so I won 25% of the time. I guess I really didn't win. I would have lost a lot of money. It's not a very good winning percentage.
I mean, depending on what you're getting.
Well, yeah, but I'm hoping to win more than 25% of the time.
What if you like, what if you do your money?
What?
What if you like putting $5 every time, you get $20 every time it's set?
See, that'd be different. But we're saying it's just a 2-to-1 ratio here. So I put 5 in, I win 10. I wouldn't win very much. I wouldn't win at all. Alright, last one here. Joe says that next throw will be a 3. Fred says that next throw will be a 2. Who do you agree with and why?
Fred,
Fred.
You agree with Fred, Kaylee. Why?
because the yellow is taller.
Because the yellow's taller, which means what happened?
The frequency is higher.
The frequency's higher, so it happened more often in the 20 rolls. Does anyone agree with Joe?
Yeah,
Trevin, why do you agree with Joe?
he's due.
He's due. Alright? You can go with that logic, right? 3 is due to be rolled. Does anyone agree with neither of them?
Yes.
Yeah.
Why?
Because.
Audrey, why?
Since it dies, like you can't predict what's going to happen.
It's a dice, right? It's an independent event. We can't predict what's going to happen. You could agree with either of them. You could agree with neither of them. No matter what happened before.
It wasn't.
Thank you. Yes.
Wasn't an option.
So, guys, no matter what happened already, anything could happen, right? It's a 1/6 chance. They're independent events.
Question.
Yeah, there's an outside. We're on day 2. Okay?
Can I use the restroom?
Yeah. Alright, does that make sense, guys? Right? That's an independent event. Just because I rolled it 6 out of 20 times before has no bearing on what I'm going to roll from here on out. Right? No matter what, it doesn't impact my future rolls. Any questions?
No.
Alright. Anna did a survey where she asked all the children in her school to name their favorite pet. The results are shown in the pie chart. If there were 800 children in the school, how many said their favorite pet was a fish? How do you figure that out? You just keep shouting these numbers at me. I don't know how to do it. You don't remember?
You do it times 8. The percentage times 8.
Do the percentage times 8?
Yeah.
4 times 8? How do you get that?
Because, well, the percentage is out of 100, and then you divide 100 by, or 800 by 100, and then you get 8.
Perfect. So you could do it 4 times 8, or you can think of it as, I'm going to multiply the percent as a decimal as 0.04 times the number of students there are, times 800. Right? Multiplying 4 times 8 would do the same thing. It would be 4 over 100 times 800, which in that case brings it to 32 as well. So it comes up to 32 children. Awesome. Part B. What is the angle measure for the sector of the pie representing fish? What is the angle measure? So how many degrees is that piece of pie? Jalen?
We could do 360 multiplied by 0.04.
Perfect. We're going to multiply 360 times 0.04. Why'd you pick 360?
Because that's the amount of degrees there are on the circle.
That's the amount of degrees there are in a circle, right? So if there's 4% of the circle being taken up by the fish, multiply 360 by it, we should get, I believe, 14.4 degrees if my mental math is correct.
Yes.
Awesome. You're getting pretty good at this. Any questions so far? Oh, the next one's where it gets a little tricky.
Ooh.
If 720 children said their favorite pet was a dog, how many said their favorite pet was a rabbit? What's that?
140.
What'd you do? Well, explain it to me. I don't know these numbers. How'd you do it? You don't know?
I don't remember.
Okay, you couldn't just.
How should we go about starting? Well, how did we? Jay, what do you think?
Because the 720 is part of like a different, like,
Like if the amount of children that say that their favorite pet is a dog is 36%.
Okay.
So if 720 children say that, and that means that's 36% of them.
Okay. So how would I put that
So
down?
you need to find what that would be at 100%.
Okay, so we need to find out how many children there were total, right? So if I took 0.36 and multiplied it by how many total students there were, I would get 720. Well, how many total students were there?
X.
X. We don't know. So we're going to put it as X. Or you could use Y, or you could use Z, or W, whatever you want to use.
2,000.
So I'm going to divide by 0.36. So X equals 2,000. There's 2,000 children who were surveyed. Which means what for how many said that the rabbit was a favorite? Multiply by 0.07. Because 7% said the rabbit was their favorite. So 0.07 times 2,000. How many children? 140, just like you said. 140 kids said the rabbit was their favorite. Awesome. One more problem with this graph. If 42 children said that the rabbit was their favorite, how many children were surveyed? So Ryan, how am I going to do it?
600.
Is your name Ryan?
Yeah.
No.
I really.
Same exact way we're going to flip it around, right? So 0.07 times x equals 42 and divide by 0.07. What do you get, Ryan? X equals 600 children.
That's a lot.
Perfect. Guys, any questions on that?
No.
No.
All right, we got like 5 more problems.
No, we have 2, but they're fine.
There's like 5 pieces. All right, line graph shows the record of time for the 100-meter sprint from 1964 to 2012. Hey, welcome back. All right, part A wants to know from the graph, what's the maximum length of time for which it remained unchanged? Someone besides Ryan, he's helped me out a lot today. I'm tired of hearing his voice. It's a great voice, but I'm tired of hearing it. Ethan. 12 years, how'd you get that? The graph, right? So wherever it's flat. I want to know the longest flat graph. Guys, shh. So, that goes from 1968 to 1980, which is a total of 12 years. Good. Approximately, what was the rate of change in the record time from 1964 to 2012? Ooh, there's some really key words in there that we've heard before. Rate of change. What else is the rate of change known as?
No idea.
Very good. It is slope.
Oh,
Rate of change is the same as slope. So, if I want to know from 1964 to 2012, I want to know the slope that it took. Well, I need to know the times, first of all. In 1964, record time was 10.06. In 2012, the record time was, it's kind of right between the two, I'm not really sure. I'm going to go with the easier one to do, 9.56.
are these like the actual records?
Yeah, I believe so. So I think it's actually 9.58. That doesn't work out as nice.
Dude, I think I could run a 100 meter in 9 seconds.
I will bet my life savings that you cannot.
I could do it.
Okay.
I would
That's
never.
How about an ice cream cone on it? How about
That's
that?
not that fast. 9 seconds.
What about ice cream on it?
Ice cream?
An ice cream cone. Anything in the 9-second range and I'll buy you an ice cream cone. Anything outside of it, you buy me one.
What about 10 seconds?
Yeah, so you can do it in
9 to 10 seconds.
Sure, I'll do that even.
Okay.
Okay, deal.
He's gonna cheat.
No, I won't, so I'll make sure to be there.
How would I cheat?
Alright, so, guys, shh. Back to the problem. Let's see, we're almost done. So, change in y over change in x. 9.56 minus 10.06 over 2012 minus 1964. Right, change in y's over change in x. I should get Negative 0.5 over 48. Right? Son, what's negative 0.5 over 48?
Negative 0.01.
Approximately to the hundredths. Negative 0.01. Well, I should probably put a label on that. Seconds per year, right? We're dropping negative 0.01, so we're dropping 0.01 seconds. Try to put seconds for it, per. So seconds per year.
We'll just put a line.
You can do seconds over a year, yeah, that's fine. Yes,
I go to the bathroom.
yes. Yes, Jalen.
Why wouldn't we do 10.06 minus 9.56?
You could, but then you just have to make sure you do 1964 minus 2012. Make sure you have the X's and the Y's matched up on top of each other. Okay? Alright. Someone have a question? Oh, quit laughing. This isn't funny.
They're being very harsh.
Jim measured the daily rainfall
Okay.
in millimeters at the same spot in his garden. Each day in the year. So 365 days. The results are displayed on the histogram below. What kind of graph is that?
A histogram.
How do you know it is?
Because it's like close.
They're touching.
There's no gap.
There's no gaps.
Literally tells us
And it tells us that right there. Very good.
She's not a twin.
Alright, so, guys,
Hey.
Paige, it's enough.
Yeah, Paige is being mean, send her in the hallway.
So, at approximately how many days was the rainfall more than 10 millimeters?
Wait, what?
Well, one thing to know about a histogram, guys. Those bars, it looks like it stretches from 0 to 5, right?
Yes.
It stretches from 0 to up to 5. It doesn't get to 5, it goes up to 5. So 4.999999, a lot of nines, really small, gets really close to 5 but never reaches it. Then the green bar goes from 5 up to 10, gets really close to 10, never reaches it. Red bar from 10 to 15, never gets to 15, but gets really close, right? That's how those histograms kind of work. So if I'm looking for how many days the rainfall is more than 10 millimeters, I'm going to go from here, that's 10, and anything over. Now, I got to figure out on how many days was the rainfall between 10 and 15. It's not really easy to see, is it? So we'll estimate. We'll do our best guess. Right, so this red bar looks like it goes up to about 70. We agree?
Yeah.
The yellow one will say 45. That's close enough. Blue one's 25. Pink one's 5. So how many days was the rainfall more than 10 millimeters? 145. Good. Alright. Approximately what percent of days was the rainfall more than 15 millimeters? Well, that would include the yellow one, the blue one, the pink one. So, what percent of days?
21.
75.
Well, it would be 75 days out of
365.
365, which is approximately
21%.
21%. Okay?
Wait, where is this rainfall from?
What do you mean? This sky?
No, but like where in the world is it happening?
Where is this happening?
Yeah.
At Jim's house.
Wisconsin.
At Jim's house.
In his garden.
Oh,
Yeah.
there's Jim.
I don't know. Alright. Approximately, what value would be the median?
Wait, how is Jim measuring the rainfall?
With a rain catcher. You ever seen those things?
No.
Okay, well you can look them up later because we gotta get through this. So, how do I find the median on a histogram like this? The frequency things. Well, how many data points do I have? If Jim didn't lie, I should have 365, right? So 365. And the median is exactly in the middle. So if I divide that by 2, it should be the, what data point?
182.
182.5. So it should be right between 182 and 183. So if I find the 182nd or 183rd data point, so that's 8, let's say this is 130. 5. 35. So if I go from the left side or the right side, I find that 182nd data point. It's going to be in which bar? 5 to 10. It's going to be in this green one, right?
What? I'm confused.
Because if I go from the left, there's 135 data points in this bar. There's another 80 in here. So by the time I get through the green one, I'm through 215 days. Right? I wanted to get up to 182. So that's inside there somewhere. If I go from the right, same thing. 5, 25, 45, 70, we said gets up to 145. So then anywhere inside this green bar's got to be 182nd data point, 182nd day. Does that make sense?
So what?
We're looking for that middle data point. So our answer then would be approximately 5 to 10 millimeters rain.
That is an approximate. Oh wait, it is.
It's an approximate. All right. Any questions? Yes, Ryan.
Why'd you make the other Histogram?